Hey everybody, I'm going to work through the test 9 and hopefully that'll be helpful to you if you've got questions on how to do the test. And of course, you can come see me in person. I love that too. All right, let's see if I can share the screen. Um, okay, connect my iPad. All right, here we go. Um, All right. Uh, the first few problems are use substitution problems. With use substitution, you want to look for, is there a composition of functions? And what's the inside function? And do I have the derivative of that inside function? So if it's helpful, that sign of x with the little 3 means the same thing as that. It's the sine of x quantity cubed. So the inside function is sine x. So I'm going to okay, well, let's see if it works to make u equal to sine x. Well, the derivative of sine is cosine x. So du equals cosine x dx. Um, so right here I have cosine x, and of course there I have dx. So cosine x dx, I've got it. I've got the derivative of the inside function, which is the key. So I can do my substitution. Cosine x dx is du. The sine x gets replaced with u, so it's 3u cubed du. All right, integrating, that's 3 times 1/4 u to the 4th plus c is just a power rule problem. So 3/4, put x back, there's my answer. All right, the next problem, hopefully it kind of looks like inverse tangent to you. But inverse tangent, or it looks like the derivative of inverse tangent, is some quantity squared. So if I want to change 4x to some quantity squared, the quantity would be 2x. So that's my inside function. So I'm going to let u be the 2x, which means that du equals 2 dx. So I need a 2 and I need a 1/2. All right, so that 2 dx becomes my du. The 1/2 needs to come along for the ride. The 2 dx is du. And the u is equal to 2x. So it's just 1 over 1 plus u squared. And that integral is arctangent of u. And then I need to put everything back in terms of x. So that would be 2x plus c. All right. What we need to notice here is that natural log of x, its derivative is 1 over x. So if I thought about this, like as a fraction, I can break it up like that. If I let u equal natural log of x, then du is 1 over x dx. So this 1 over x dx, 1 over x dx becomes du. Okay? And natural log of x gets replaced with u. And oh, well, the integral of 1 over u is natural log of absolute value of u plus c. And then u is natural log of x. So there is my answer. All right. If you missed this problem number 2, you were in the majority of people who missed it. The chart just has f of x, f prime of x, just x being plugged into the function. Notice I have 2x. So I need to rewrite this function so I have just a single variable as the input instead of 2x. So that is a situation for u substitution. All right. I mean, basically 2x is my inside function. F double prime's my outside. So I'm going to let u be that 2x, my inside function. Of course, the derivative of u then would be 2 dx. Let's put it down here. So it's from 1 to 3. I need a 2. So I have to have a 1/2 to offset that. F double prime of 2x dx. All right, so the 2 dx becomes du. So 1/2 du, and the 2x, right up here, 2x is u, so I can replace the 2x with u. I need to change my limits of integration. So 3, plug it into here, becomes 6. My lower limit is 1, plug it into here. When x is 1, u is 2. So that would be from 2 to 6. So that's 1/2. The integral of f double prime would be f prime of u. And I'd be going from 2 to 6. So it's 1/2 f prime of 6 minus 1/2 f prime of 2. And f prime of 6, this is where we look at the chart. F prime of 6 is here. F prime of 2 is there. So I'm going to be doing 1/2 -2 minus 1/2 5, which is going to be -7/2. All right, a lot of people had -7 on that answer. They didn't have the 1/2 because they didn't really think through and do the u substitution, okay? So like I said, if you had -7, that was a common mistake. All right, going on to the next page, we're doing definite integrals here. I don't just have e to the x, I have e to the x squared plus 2. So I have a composition of functions, e to a power, and the x squared plus 2. And what I got to check is, hey, do I have the derivative of x squared plus 2? Well, the derivative would be 2x dx. And I see, yeah, I do have an x. Of course, I have the dx. I do need a 2, so I need to do a 2 and a 1/2. So I think I could do the substitution. The x dx becomes du. The e to the x squared plus 2 is just e to the u. All right, let's put the 1 in here. I get 3. If I put 2 in here, I get 6. So I'm going integrating from 3 to 6. Integral of e to the u is just e to the u. I evaluate from 3 to 6. And that's it. And just a little side note, for some reason, I had a fair number of people who wanted to say that e to the 6 minus e to the 3 equals e to the third. And it does not, folks. You cannot combine those. All right. Again, looking at where I might have composition of functions. 2x squared plus 1 is being raised. It's really being raised to the -2 power because it's in the denominator. But this is basically my inside function. So I'm going to let u equal the 2x squared plus 1 and see if it works out. Do I have that derivative? Well, the derivative would be 4x dx. And luckily, yeah, I've got an x up here. I don't have a 4, but I can fix that. This negative, I don't really need it, so because there's no negative over here. So I'm going to pull the negative out. I'm going to have to do a 1/4 and make that a 4x. Okay, so the 4x dx, that's the du. So I have -1/4 du 1 over, and I replace the x squared plus 1 with u. So 1 over u squared. All right, I need to plug 0 into here. I get 1. If If I plug 1 into here, I get 3. So I'm evaluating from 1 to 3. Sometimes people get confused and they see a variable and a denominator and they think natural log. It's only natural log if it's the variable to the first power. This is u squared. So when it's here, I'm going to rewrite it as u to the negative 2. All right? It's just power rule, guys. So you add 1 to the exponent. You have to multiply by a negative. So that's going to become a positive 1/4 from 1 to 3. So I have 1/4 times 1/3 minus 1. That's 1/4 times negative 2/3, which is negative 2/12, which is negative 1/6. That's my answer. Hey guys, this one you did not need to use substitution for. It's the integral of secant squared is just tangent x. So you did need to know a little unit circle here. Tangent of pi over 4 is 1. Tangent of 0 is 0. Your answer is 1. All right. Folks, this was lesson 5.8, which fair number of people seem to forget about. G of x is equal to 2 to 6x. So g of 1/3 would be the integral from 2 to 6 times 1/3 of the square root of 2t minus 1 dt. But 6 to the 1/3 is 2. So it's integral from 2 to 2 of 2t minus 1 dt. Anytime your upper and lower limits of integration are the same, the answer is just 0, because remember, that's just a line. So there's no real area. Anytime you have a function defined with an integral and you want the derivative of that function, it really turns out to be pretty easy. You just take your limit of integration and you replace t with it. Because essentially here you would be integrating whatever the square root of 2t minus 1, and then when you take the derivative, you get that back. So they're like the integration and the differentiating are undoing it. However, I do plugging in 6x, that's kind of like chain rule. So I'm going to plug in 6x for t, but I have to multiply by the derivative of my inside function, which is the 6x. Now the denominator is 2. When you have a constant, when you plug that in, you just end up with 0 because you'd be multiplying by the derivative of 2, which is 0. So it is minus 0. You don't have to obviously write that. So it would be 6 out in front, 12x minus 1. That's your answer. Then g prime of 2 is just plugging 2 into that. So that equals 6 times root 23. All right, again, let me know if you need help with that. All right, number 5 is just basically chain rule. Because notice I have f of g of 4 and f of g of 2. So that means the function would have been f of g of x, and I would have had to use chain rule to take that derivative. So remember, the derivative of f of g of x is f prime of g of x times g prime of x. Right there, guys. F prime of g of x, g prime of x. And when I integrate it, I'd be plugging in the 4 and the 2, which is what I see here. All right. Mean value theorem for integrals. The value of c guaranteed by that theorem. So what we need to find first is the average value of the function, which is a y value, right? And then we're going to find the value of x that I can plug into the function that gives me that y value. All right, so first of all, to find the average value, I just do 1 over the width of the integral, sum up from 0 to 8, the function. Okay, x to the 1/3 would be x to the 4/3 with a 3/4 in front, minus x from 0 to 8. So that's 3/4 times 8 to the 4/3 minus 8, minus plugging in zeros, pretty easy. 8 to the 4/3. Okay, that means the cube root of 8 to the 4th power. That's 2 to the 4th power. That's 16. All right, so 3/4 of 16 is 12. 12 minus 8 is 4. So I have 1/8 times 4, so I have 1/2. Okay, that's the average value of the function. The mean value theorem says there is some x value, which we'll call c, such that when I plug in that value into here, I will get the average value, which is 1/2. So 1/2 equals x to the 1/3 minus 1. Set the average value equal to the function and solve for x. Okay, x to the 1/3, so I need to cube both sides. I have 27/8 equals x. There we go. The answer was C. Okay. Just a quick reminder of what we are doing here. From 0 to 8, we have some function. I don't know, x to the 1/3 minus 1. No, I don't know. Something like that. And what we found was that the average of all the y values was 1/2. And so it's like, okay, that area, this area would equal, wrong, I need to change colors. Okay, would equal that area. That makes sense. And there's somewhere where the function has an x value that when you plug that value in, which for us was 27/8, into the function, you get 1/2, which is the height needed to make a rectangle that has the same area as the area underneath the curve. Okay, just kind of a little refresher what mean value theorem for integrals is all about. All right, average value of f. We used that concept in the last problem. The width of my integral goes from -5 to 4, so the width is 9. And then I sum up all the values of the y's, basically. Again, an informal way to think about that with integration. How do I find this integral? Some of you were trying to actually like integrate, but when you have a graph like this, you want to use geometric formulas. So I'm going to look at the area between the function f of x and the x-axis, and keep in mind that any area underneath the x-axis is considered negative. All right, so this little rectangle, it's a 2 by 2. So its area is 2. This rectangle is 5 by 4, so that area is 10. This rectangle is 2 by 4, so that area is -4. So it's going to be 1/9 times the 2 plus 10 minus 4, which is 8/9. Okay. All right, find the area of the region enclosed by the graph of y equals x squared plus 1 and the line y equals 5. All right, so yes, you do have to know how to graph x squared plus 1, which is just a parabola raised up 1. The line y equals 5 is a horizontal line here at 5. The area that I'm looking for then is this area. Not the best job of shading, sorry guys. I need to know these x values so that I know my limits of integration. So in order to find them, I set my function x squared plus 1 equal to 5. That means x squared equals 4. That means x equals plus or minus 2. So these x values are 2 and negative 2. So I'm going to be little vertical rectangles work perfectly here. So I will be integrating from negative 2 to 2. My top function is 5. My bottom function is x squared plus 1. So the y value here of this rectangle is 5. The y value down here is whatever x squared plus 1 is. So I subtract those y values, that's what I'm doing over here, to get the height of the rectangle. All right, so that's negative 2 to 2 of 4 minus x squared dx. Integrating, I get 4x minus 1/3 x cubed from negative 2 to 2. Plugging in, I get 8 minus 8/3 minus negative 8 plus 8/3. Yep. All right, so I like to do the whole numbers together. 8 plus 8 is 16. Negative 8/3 minus 8/3 is negative 16/3. So that's 48 minus 16 over 3, which is 32/3. All right. And the last integration problem, or the last area problem, or the last problem on the test. And you just had to set up the integral. If you were to do for vertical rectangles, notice how what's the top for all of these is 5, but the bottom changes. Here it's the line. Here it's the x-axis. Here it's the parabola. I know it says square root, but square root's just half of a parabola that's been turned on its side. So it's different functions. I would have to divide it up and do just from 0 to 2, then 2 to 4, then 4 to 8. We want to do one integral. Okay, some of you did break it up. And since I hadn't specifically said that you had to do only one integral, I did give you credit for it. But on the next test, it's going to say, hey, you can only do one integral. So I'm going to force you to do integrate with respect to y. And if you do little horizontal rectangles, their right endpoint is always on the parabola, and their left endpoint is always on the line. So I can just do one integral. My lowest y value is 0. My highest y value is 2. So it's going to be from 0 to 2. All right, this function is f of x equals the square root of x minus 4. Remember, since I'm integrating with respect to y, I need to have the function solved for x. So I replace f of x with y, square both sides, and y squared plus 4 equals x. So that's my first function. All right, this function is g of x, which I'm just going to go ahead and replace with y equals negative x plus 2. So if I bring x over, I have x equals 2 minus y. So 2 minus y is my other function. Right there, that's your answer, folks. All right, and I will show you the bonus. This is a technique that is used, that you do need to eventually learn. I think in BC, we don't really do it in AB. But it's fun, and it's not that hard. Okay. You're told what the u substitution is. Okay. The derivative of u then would be 2x dx. So looking at this integral, you know, the x squared plus 1, that's going to get replaced with u. I have x cubed here. This is just an x. Okay. So I'm going to rewrite this integral from 0 to 2. I need just the x. So I'm going to separate it into x squared times x. I also need a 2. Okay. So 2x dx. 2x dx. I got the 2x dx. The x squared plus 1, that's going to be my u. I still have x squared here. You can't have both x's and u's. You have to only have all x's or all u's. But looking at this equation, could I solve it for x squared? Yeah, u minus 1 would equal x squared. So I can replace x squared with u minus 1. So u minus 1 over u du. Limits of integration, 0 becomes 1, 2 becomes 5. And this 2 can come into the denominator there. So that's 1 over 5, u minus 1 over 2u du, which is that. All right, guys, I hope that was helpful. This is not meant to replace my helping you guys, so come see me, and we're all going to have really good retakes. All right.